Hey everybody! We're going into some more detail now about sound waves and how we describe the different parts of them, and we'll be looking at sound wave graphs as well. So your learning intentions are, you should be able to interpret the pitch and the volume of a sound wave graph when we draw them, and you should be able to analyze the wavelength, the frequency, and the amplitude of a sound wave. And we'll learn all those words right now. Okay, so the first thing is, scientists have come up with sound wave graphs because they help us to actually visualize the sound wave and show more information than you can by just drawing out the longitudinal wave like this. Plus, it's a lot easier to draw a line graph than having to draw thousands of dots to show the wave. So we should already remember that sound moves as a longitudinal wave, and the parts here where the particles are compressed, we call the compression, and where the particles are spread out, we call the rarefaction. But this down here is how we actually draw that in a sound wave graph. Okay, so like I said, they help us to visualize a sound wave. And make it a bit more clear about the type of sound that it is. So the first three things we need to be able to do is describe the different parts of a sound wave graph. So what we do when we draw them is the parts of the wave that are a compression, we draw as having the line higher up on the graph here. And the tips of the graph we call peaks. So the peaks represent the compressions. And then as the sound wave graph goes down, that's representing the rarefaction, where there's not many particles compressed together. And we call those troughs. Troughs like an animal trough that they eat out of, because it looks like the bottom of a food container. So the troughs, they represent the rarefactions. And we draw a line along the middle of the graph here. We call that the origin. That's just telling us the average of the graph. But it is important for later when we talk about amplitude. So we'll come back to talking about the origin later. But that's a sound wave graph. So it's much easier to visualize and to see what's going on with the sound. Okay, the next thing is we need to be able to describe these different words to do with the sound wave graph. So the three words are amplitude, wavelength, and frequency, which I'll put down here. And all these words describe a sound, and they tell us how loud it is, and they tell us the pitch. So they relate to what type of sound actually is it. Okay, let's start with amplitude first. So we can see here on the graph here in blue, the amplitude, it's actually the measure of how high up the sound wave is on the graph from the origin. So it's not the whole distance, it's only half the distance up. So the distance from the origin up to the peak of the graph. And amplitude, well, it tells us how loud the sound is. Tells us the loudness of the sound. So if you see a sound wave graph that has an amplitude that's up and down and going really high up and down, that's going to be a loud sound. But if you have a graph that's not going up and down very much, in other words, it doesn't have a high amplitude, that's going to be a quiet or a soft sound. Okay, the wavelength and the frequency, they're to do with the pitch. So you can see here, the wavelength, it's a measure from the top of one peak to the top of the next peak. Or you can measure it from one trough to the next trough. Or you can measure it from the start of one wave until it does a whole complete cycle to the start of the next wave. So you can see all those distances are the same. It just has to be from one point to another. So we can define it by saying it's the distance from one point in the wave to the same point but on the next wave. From one point on a wave to the next wave and the same point. And what the wavelength tells us is how high or low pitched it is. It tells us the pitch of the sound. And we'll come back to that in a second, but we'll jump over to frequency now. So frequency, that means if you're standing at the end of the wave here, the frequency is counting how many waves are going past you every second. And in other words, how much the wave is vibrating and how quickly. So it's how many waves per second. In other words, it's the speed of the vibrations. And it also tells us the pitch. Okay. And wavelength and frequency are basically the opposite. So if we have a graph that's got a really long wavelength, that means the waves are really spread out, like this one. So if there's a long wavelength, that is a really low pitch sound. Really deep, like a male voice or a bass drum. But if you have a really short wavelength, then that means that graph is going up and down really quickly. And that is a high pitch sound. Someone screaming, a bird chirping, any kind of high pitched sound. And frequency is the exact opposite. So if there's a long wavelength, like in this one, it's a long wavelength, this has a low frequency because it's not going up and down very quickly. And the opposite's also true. So if you have a really short wavelength, like in a high-pitched sound, you have a high frequency because it's going up and down really quickly. Okay, here's a couple more examples. We've got a high frequency wave, and in a high frequency wave, we've got a short wavelength. And you can imagine a violin. The notes it plays have a higher pitch than other string instruments. And then if there's a low frequency wave, well, those wavelengths are much longer between each one. So in a low frequency, you've got a longer wavelength, and they cause a lower pitch sound. And if we're talking string instruments again, your double bass is a much lower pitch sound. When you pluck the strings or when you play them with the bow, it's got a lot deeper notes than a violin does. Okay, so you should be able to explain sound wave graphs, talk about the peaks and the troughs, and you should be able to explain the amplitude, the wavelength, and the frequency of a sound wave.